Thank you, John. That was an excellent little bit of experimentation to do. Let me just share mine. This is my case study. Isn't one to do at home yourself, and I'm just trying to. Right, how's that?
Yep.
Okay, thanks, John. That was a really interesting presentation, and so was Andy's, in fact. Both really gave me some food for thought too, in fact, which is really good. Yes, this is not an experiment to try at home, this use case or aviation case study. In fact, you said last time, you know, a decent nav system should use inertial first. Well, in aviation, you know, inertial technology has been around for a long time. Combine it with GPS, what could go wrong? Well, when I've presented this in the past, I've actually said that the cause of it was that the captain of this aircraft forgot his earmuffs, and it's not a million miles out. This shows exactly what happens if you design or try to provide some mitigation for the vulnerabilities of GPS and you don't think enough about the use case involved and the systems involved either. And this chain of events happened because the captain forgot his earmuffs. And because the captain forgot his earmuffs, he could not do the walk round check of this Airbus A330 that was parked on the ground in Sydney and flying to Kuala Lumpur. So, so he asked the first officer to do it. And the first officer then did the walk round, and the captain had to input the ramp position of the aircraft into the inertial navigation system, which he did. But it was about 6,000 miles out, and the first officer didn't notice because he was checking the outside of the aircraft for doing a pre-flight. They didn't notice or check it because they were busy. And when the aircraft was rotated off the runway in Sydney, all of the navigation systems on the aircraft went blank. There was, in fact, a very small indication that you might have noticed that said that there was a GPS problem, but you'd have had to be in a clear, calm situation probably to have noticed it. And what had happened was the aircraft systems had noticed a discrepancy between the GPS position and the inertial navigation position. And because of the vulnerabilities of GPS and its susceptibility to interference and jamming, the arbitration of the system was set to deny GPS because that seemed to be the safe course of action. And of course, the consequence of that was that the aircraft then tried to the aircraft systems then tried to deal with the fact that they were supposed to be 6,000 miles away. So that didn't work either. And it just shows how this can happen. That the ramp position entry wasn't cross-checked with the GPS position. The safeguard invalidated the GPS signal. In fact, if the GPS signal had been used to input automatically the ramp position, which some options of the systems on these aircraft do have, it would have been the best thing going. But whatever, the system response was probably intended to address the GNSS vulnerabilities. The flight crew couldn't find out what the problem was. They were obviously under heavy workload. They couldn't land back at Sydney because the weather was not good enough. And the air traffic control, the air traffic controllers had to vector the flight crew to a landing in Melbourne, which is absolutely incredible, really. And obviously, this sort of thing could only happen once, right? In fact, here's another one that happened in 2007, very similar incident. The gyro compass ended up having a heading error of 40 degrees because of a longitude that was incorrectly set by maintenance. And again, we had that disagreement with GPS data. And so there are two examples right there of early attempts, if you like, to mitigate, you know, the vulnerabilities of GPS with an incomplete understanding of the system and of the use cases. And that just shows you that actually sometimes you can try and add resilience, but if you do it incorrectly, the result might be worse than if you hadn't bothered putting any mitigation in at all. And I think both of those incidents, the truth was exactly that. So again, the insights really, yes, you need that systems approach to implementing and shooting for PNT resilience. You have to have a fantastic understanding of use case and mission profiles. You've got to engage with experienced users. It's no good trying to think that you understand the issues that someone with experience in a role has had for a long time. You need to try and do some digging and find out what they do, exactly how they do it, what can go wrong. It's very difficult to do it. And also, something we haven't perhaps talked about a lot today, and John, I know, would tell you he could run another course on this, human factors. As soon as you add a human into the loop with resilient PNT, and things get even more complicated. And again, adding resilience can add other vulnerabilities to a system. This one here meant that there was a dependency on someone making sure that the ramp location had been keyed into the aircraft system accurately all of the time. And root cause analysis, obviously important, understand the what ifs. But I think that was just to emphasize the importance of carrying out improvements to resilience in a very complete manner, and getting it wrong is very easy to do. And I think with that, I shall hand back to John.